Welcome, students, back to chapter 6. So we're going to switch gears a little, focus now not on kind of the anatomy of our bones and skeletal tissues, but some processes, some physiology associated with our bones and skeletal tissues, starting with how we get them, right? How do our bones develop? So the proper term for bone development is ossification or osteogenesis, formation of bony tissue. That's literally what those words mean. And ossification takes place kind of three periods, right? So we have kind of prenatal, kind of in utero, which is the actual formation of our bony skeleton. Typically starts around the second month of development, about 8 weeks or so. And then we have kind of all of our childhood growth processes that occur postnatally, so we can get taller. And then we also have this kind of lifelong remodeling and repair that also takes place. So when we think of our life postnatal, right after we are born, right, we have childhood and we also have adulthood. And so different things go on, kind of those three different life stages. When we're in utero, we get the formation of our skeleton. When we're children, we get a lot of what we call interstitial growth, so we can get taller. But then even when we're adults, we're still getting ossification and osteogenesis taking place through the remodeling and repair processes. Yes, all of us remodel. So even if you've never broken a bone before, you've had remodeling going on in your life. So we're going to start with kind of the prenatal formation, how we actually get our bony skeleton. There are two types of ossification that take place in utero, what we call endochondral ossification and then intramembranous ossification. Let's break these two words down a little bit. Endochondral, endo within, inside, chondro, cartilage, so within cartilage. These bones, which is most of the skeleton, actually start off as hyaline cartilage models. And those little cartilage models are then replaced by bony tissue. Now the flat bones, the clavicles, the cranial bones, they take place through intramembranous, so intra within, membranous within membranes. So these bones develop not by replacing hyaline cartilage models, but within some kind of fibrous, kind of mesenchymal membrane tissue. So let's look at endochondral ossification first. As I mentioned, it typically starts around week 8, week 9, so about 2 months into the gestational period. Before that, we do not have bony tissue. We have these little hyaline cartilage models. So the first thing that happens is we get the formation of some compact bone, as what we call a bone collar, around the diaphysis of the hyaline cartilage model. That kind of cuts off oxygen and nutrients to the hyaline cartilage, because remember, they don't have any blood vessels, and so our private ossification center begins to appear. The cartilage in that diaphysis kind of deteriorates. The quote-unquote bone is actually cartilage, so it's cartilaginous growth, and as the cartilaginous quote-unquote bone grows in length, the deteriorating bit of cartilaginous tissue in the middle of the diaphysis and then expands to keep up with that growth. You'll get an invasion of what we call a periosteal bud. It's essentially just an invasion of some blood vessels that go into that kind of developing cavity. That brings oxygen, nutrients, lots of osteoblasts, and we start to lay down some spongy bone. The cartilaginous quote-unquote bone will continue to grow in length through interstitial growth of the cartilage, but as the cartilage bone grows, the spongy bone will continue to grow, the diaphysis will continue to elongate. Secondary ossification centers will appear in the epiphyses when they are also invaded by blood vessels, and by the time we are born, we will have 2 ossification centers, a pretty well-developed medullary cavity in the diaphysis, and that is kind of how we will remain through most of childhood up until about adolescence or so, with the diaphysis with its medullary cavity 2 epiphyses of spongy bone, and all that remains of the hyaline cartilage model is the articular cartilage on both of the ends, as well as the 2 epiphyseal plates, which will be our growth plates, in order to continue to allow us to get taller. So this is a slightly more complicated process because we have to replace the cartilaginous tissue first. Intermembranous ossification isn't quite as complicated. So this is our skull and our kind of flat bones like the clavicles. So our skull actually starts off not as cartilaginous tissue, not as bony tissue, but as kind of this kind of fibrous membrane. In the middle of that fibrous membrane, we'll get an ossification center forming with some osteoblasts, usually quite centrally located, nice little cluster of osteoblasts. Those osteoblasts will start to secrete what we call the osteoid, so it will start to secrete the extracellular matrix of the osseous tissue. We'll get kind of our spongy bone or our woven bone forming first. Blood vessels will invade the woven bone. That brings oxygen, nutrients, more osteoblasts. Eventually, the lamellar bone, the trabecular bone, actually replaces that initial kind of woven bone. Red marrow will start to appear within the cavities, and will start to develop compact bone on the outer edges just underneath that periosteum that makes those kind of sandwich plates. And the skull bones, you'll usually have several kind of ossification centers forming in each of our skull bones, and then they will eventually all fuse together. So that is what happens internally in utero in order for us to actually get a bony skeleton. But once we have a bony skeleton, well, we all start off pretty tiny. We got to get a whole lot taller. And so now we're talking about kind of childhood growth. And again, it's 2 processes. Interstitial growth is the longitudinal growth, the growth in the length of our bones. But as our bones get longer, we also have oppositional growth occurring to increase the thickness of our bones so that we don't end up with these really long, spindly bones that have completely unequal proportions. So as the bones get longer, we also want them to get a little wider as well. So interstitial longitudinal growth occurs at those epiphyseal cartilaginous plates. Now the plate itself throughout childhood will essentially maintain a constant thickness. Cartilage will grow on one side, lengthening the overall bone, but the older cartilage is then replaced with bony tissue, so as the cartilage grows, the bony tissue kind of keeps up with it. And typically, you'll get some remodeling, particularly at those ends of the bones, the epiphyses, to again maintain proper proportions. So we are looking at our growth plates. So what you see here and here are not fractures, because we're looking at the knee of a child. So this is our plate. The resting zone is closest to the epiphysis. The ossification zone is closest to the diaphysis. So we're looking at it this way. So the resting zone is where we have cartilage being cartilage, basically. Nothing much is going on there. The proliferation zone is where those cartilaginous cells, you can see they're pretty tightly packed in here because they are undergoing mitosis, so they're making lots and lots of copies of themselves and lengthening the bone that way. The older cartilaginous cells are in the hypertrophic zone. These older cartilaginous cells are quite large, hence the reason we call it the hypertrophic zone. Here in the calcification zone, the cartilage is starting to die off, the cartilaginous matrix is beginning to deteriorate, and we're beginning to incorporate calcium crystals into the extracellular matrix. But it's not until we're as close as possible to the diaphysis where we're actually getting ossification taking place, where new bone is forming. So essentially what happens is, like, the cartilage grows and proliferates. That pushes the epiphysis away from the diaphysis and lengthens the overall bone, and then the formation of the bony tissue here in the ossification zone kind of keeps up with it. So as the bone lengthens with cartilage, the older cartilage is replaced with bony tissue. And so essentially it's just kind of keeping up with each other. As the cartilage grows, the bone grows, and that gives us this growth in length that occurs throughout childhood. Now, as we hit kind of post-pubescence, kind of the end of adolescence, those chondroblasts that are in that proliferation zone making new cartilage start to become less active, and the plate will get thinner and thinner and thinner as the kind of cartilage is replaced by bony tissue. And then typically at about 18 for females, about 21 for males, the plate itself will completely close. The epiphysis bone and the diaphysis bone will completely fuse. That cartilaginous plate is no longer present. That's when we have the epiphyseal line. And at that point, you're done. You're not getting any taller. The interstitial growth of your bones will cease. Now, appositional growth is the growth in width of our bones. And appositional growth actually doesn't stop. So unlike interstitial growth, which stops kind of late teens, early 20s, appositional growth takes place throughout your lifetime. It occurs underneath the periosteum, where osteoblasts will essentially just secrete new matrix underneath on the external surface of that bone. And as we kind of get wider on the outside of our bones, on the inside around the cavity, around the endosteal surface, the osteoclasts will remove the bone so that the bones don't get really thick. So as the bones grow wider, the medullary cavity itself kind of also goes wider. Typically throughout childhood especially, there's usually a lot more building up than breaking down, but mostly it's about striking a balance, right? We want the proper thickness, we want the proper strength in our bones, but we also don't want them really heavy. So you can see here we have our epiphyseal plate. You can see here's our articular cartilage. So you can see the articular cartilage and the epiphyseal crate cartilage is essentially replaced by the bony tissue, whereas the bone over here has been kind of remodeled and resorbed. So as we get wider this way, you know, we're losing some bony tissue right here during that appositional growth. So the growth occurs here under the periosteal surface, but as we're getting wider this way, the medullary cavity itself is also getting wider. So that maintains kind of the proper thickness of our bones. Bone growth is very hormonally driven. There are several hormones that are involved in regulating our growth of our skeleton. One of them is made by the pituitary. It's called growth hormone. It is by far the most important hormone in terms of stimulating the activity in that epiphyseal plate. Without growth hormone, you can end up with what we call pituitary dwarfism, people that are very short. If you have excess growth hormone, we have gigantism, people that are very, very tall. So typically we want just the right amount. Thyroid hormone also plays a role in bone growth. It kind of modulates, kind of tamps down some of the activity of the growth hormone. It's mostly about making sure that we get proper proportions in our bones. And then our two sex hormones, testosterone in males, estrogens in females, those are responsible for two things, actually. They are responsible for the kind of adolescent, kind of pubescent growth spurts that we get. I remember my nephew, He is about 2 years older than his sister, and he was like a freshman in high school, and his sister was taller than him, and he was really unhappy about the fact that his sister was taller than him. But then he got a little burst of testosterone, and now of course he's over 6 feet tall. And significantly taller than his sister, who is actually still quite tall for a girl. The other thing that our sex hormones do is they actually induce the plate to close. So they're responsible for like that last little burst of growth that we get when we hit puberty, but they also are responsible for ending the growth in the length of our bones. If you have an excess, too much or too little, so an excess or a deficit of any one of these hormones, growth hormone, thyroid hormone, or one of your sex hormones, you will tend to end up with fairly abnormal skeletal growth, either bones that are too wide or bones that are too long, or just completely kind of malformed and without proper proportions.